Assalamualaikum warahmatullahi wabarakatuh. Today our group will present our topic for task 1, which is population of diabetes patient in Malaysia from 2006 to 2020. Our group members are Arni Sufia, me myself, Muhammad Aiman, Nur Ain, Nurul Fasiha and Nurul Nabila. We begin with the background of the diabetes. Ashra, an Egyptian physician, reported repeated urination as a symptom of a mysterious disease that also triggered immunization in 1552 before century, which was the first recorded mention of diabetes symptoms. Diabetes is a long-term disease that affects the way our body transforms food into energy. As we know, most of the food we eat will be broken down and converted to glucose, then this glucose will be released into the bloodstream. And when the blood sugar level rises, the pancreas is prompt to release insulin. However, for a person diagnosed with diabetes, the body either does not produce enough insulin or cannot use it as effectively as it should. Next, the ancient Egyptians first identified diabetes mellitus 3,000 years ago. Eratosthenes Cappadocia was the first to introduce the word diabetes, while in 1675 the word mellitus, which means honey sweet, was added by Thomas Willis. In 1776, the presence of excess sugar in urine and blood as a source of sweetness was first confirmed by Dobson. And the first major discovery that led to the use of insulin to treat diabetes occurred in 1889. George Zilzer, a German scientist, discovered in the early 1900s that injecting a pancreatic extract to patients could help regulate diabetes. In 1920, Frederick Banting came up with the use of insulin to cure diabetes, and he and his colleagues started their hypothesis on animals. In 1922, Banting and his teams used insulin to successfully treat diabetic patients, and a Nobel Prize of Medicine awarded in the following year.
Next, according to the Malaysian National Health Mobility Survey 3, diabetes mellitus was found to be prevalent in 11.6% of population in 2006. The highest prevalence was 19.9% among Indians, followed by Malaysians at 11.9% and Chinese at 11.4%. However, in 2020, according to the Health Ministry, diabetes now affects nearly 18.3% of Malaysian adults. Looking at the increase in population of diabetic patients with time, it relates to the growth problem. Thus, we can use this information to predict the population of diabetic patients in the future by obtaining the particular solution from the growth problem solution. There are many factors that increase the risk of diabetes, which are diseases in pancreas, infection or illness, impaired glucose tolerance, insulin resistance, family history, and so on. This showed that diabetes is the major non-communicable disease, and we must identify all the cases in order to provide comprehensive care for the patient's benefit and to halt the spread of diabetes in Malaysia. Next, the objective of this research are, firstly, it is to identify the population number of diabetes patients in Malaysia for the years 2006 to 2020. Secondly, it is to estimate one past and future value of the population number of diabetes patients using a particular solution and compare with the historical value. Thirdly, it is to determine the factors that affect the population number of diabetes patients. And lastly, it is to model the population number of diabetes patients with a first-order differential equation based on the multiplication growth model.
Next is implementation. For methodology, in the task, our group has chosen one topic about the growth population, which is population number of diabetes patients for adults above 18 years old in Malaysia for 2006 until 2020. We collected the secondary data with an exponential graph outcome from the website Ministry of Health Malaysia. The data of the selected years is being transferred into the table 1. Table 1 shows population numbers of diabetes patients for adults above 18 years old in Malaysia in 2006 until 2020. Next, in this task, we use a basic derivative equation which is a matrix growth model. This model shows how the population number of diabetes patients for adults above 18 years old in Malaysia changes with respect to time. The matrix growth model is given as Pt equals to A exponential power of Kt, where Pt is population in at time, T, A is initial population size, K equals to population growth rate, and T equals to time. The model can be written in the form of differential equation as dp over dp equals to kp.
In this study, the population growth problem is modeled by using the Matussian model, which is P in bracket T equal to A exponent Kt. Based on the data in the table 1, the values of A and K are calculated by applying a few steps of solving the differential equation. Hence, the particular solution is obtained. The computation process is as the following. Firstly, let Pt, the number of diabetes patient population for adults above 18 years old in Malaysia at time, which is time in year. The equation is dp over dt equal to kp, where k is a constant of proportionality. By integrate this equation, we can get the general solution, which is p equal to exponent kt plus c, and it can be simplified into p equal to a exponent kt, where ac is a. Next, by using the initial condition t equal to 0, which is in 2010, the value of population is 2,001,000. From that, the general solution becomes p equal 2,001,000 exponent kt.
After that, by using t equal to 1, which is in 2011, the value of population is 2,002,000. From that, we can get the value of constant k. After solving several steps, the value of constant k that we got is 0.04652. And lastly, the particular solution now becomes p in bracket t equal 2,001,000 exponent 0.04652t. Based on the particular solution, a simple calculation is carried out to calculate the population of diabetes patients for adults above 18 years old in Malaysia from 2006 until 2020. The population number is based on the actual data and the estimation using a particular solution. Aside from that, the graph of particular solution is plotted using Desmos software and shown in figure 2.
We move on to the next section of the presentation, which is the data analysis and discussion. As we can see in the first figure, it can be clearly seen that the figure is about the population of diabetes patients in Malaysia, and we can see that it has an upward trend, and the highest cases are in the future or in the present, which is 3.2 million cases recorded. The second figure is about particular solution of population of diabetes patients in Malaysia using Desmos. The vertical axis is about the population of the diabetes patients, and the horizontal axis is about the year. And as we can see, as the years goes on, the numbers of patients increases exponentially. Now, we're going to be calculating the estimated value of the past and the future. So, by using the particular solution, which is in this case, Pt equal to 2,100,000 exponent to the power of 0.04652 times t. So, to calculate the past 4 years from the 0, which is 2010, we're going to be placing negative 4 into the t. So after that, we're going to be getting 1,743,435.07. And next, to calculate in the future, which is 10 years after the 0, which is 2010, so we're going to be placing 10 in the t, which is in the particular solution, and we're going to be getting 3,343,898.51. Now we're going to be calculating the percentage error for the year 2006 and 2020. So we're going to be using formula population estimated minus population actual over population actual modular times 100% to calculate the percentage error. And for the year 2006, we're going to be getting 3.142% of percentage error, while in 2020, we're going to be getting 4.5% of percentage error.
Why does the estimated value are way ahead of the actual value? The first factor are many new medical discovery has been found. In 2020, according to Longjan Dineshwari in a study published in Nature Biotechnology in March, researchers from the Washington University School of Medicine in St. Louis demonstrated that human stem cells could be turned into insulin-producing beta cells using a new technique. The researchers believe that transplantations of billions of such cells could effectively lead to a cure for type 1 diabetes. However, in-depth research still need to be done before this strategy can be used to treat people with diabetes. There are also a group of researchers from the Salk Institute in the United States where they created pancreatic cell clusters that can avoid detection by the immune system. The second factor is comprehensive strategy and approach by the Malaysian government to improve prevention, treatment and control of diabetes as an urgent response to this growing chronic disease. Other than that, Minister of Health surely has monitored every aspect of it by holding many health awareness campaigns to give awareness to the community regarding this matter by having a healthy lifestyle. Lastly, advanced medicine. With many research has been made, new medical breakthroughs in diabetes healing medicine are getting better. An article mentioned that the rise of the diabetes cases is due to the high carbohydrate and fat-rich food intake by the Malaysian people in 2006, making the actual diabetes cases higher than the calculated cases. Besides that, lack of awareness and knowledge on diabetes. People in rural and urban area are less aware on the disease, leading to people not getting enough medical attention on their health. The factors that affecting the high number of diabetes cases in 2020 is probably due to the COVID-19 pandemic. Due to the inability to go out during MCO seasons, many people find that fast food, which have high amount of sugar, is the only easier food option for them to have. Other than that, negative lifestyle also one of the reasons. Many people become less productive and lack of physical activity during the pandemic, which may causes an increased cases of type 2 diabetes.
As for the conclusion, the benefits that we gain from the mathematics group project assignment are we are able to reinforce skills that are relevant to both group and individual work. Moreover, we properly structured this group project by dividing the tasks and parts to each member. This will make sure that everyone contributed fairly to the project. For this task, we are able to find the data with the specific here, which is the population number of diabetes cases for adults above 18 years old in Malaysia for 2006 to 2020. And we have also known how to predict the future and past population using a particular solution, which is differential equation. We chose 2021 as our future year, while 2002 as our past year's value. After that, we compare the historical value with the experimental value just to get the accuracy. And last but not least, we also figure out what has affected the population number of diabetes cases in Malaysia.